right, so let's get started. Welcome everyone to another community meeting. And I see familiar faces, familiar names, not familiar faces here. So yeah, I hope everyone had a good month. And first, let me give a quick update of what's going on with the new release. I know it has been really delayed. What's holding up and what's expected timeline. And then I'm going to talk a little bit about the WASM IO conference, which happened last week in Barcelona, or the week before. That's so. It's I think it's the first gathering of the WebAssembly community. Since Detroit last year. So, I think there's lots of interesting topics that came out. So I'd like to give you guys an update. So, and after that, we're gonna have Mr. Zhang Heng talk about sqlx, which is, I think I've categorized it as the JDBC for Rust. It's not really an ORM, but, it's a dynamic database connector that can connect to multiple database backends. So how to use that in a Rust application and then compile to WebAssembly and run it in WasmEdge. So I think that's would be a really interesting topic because we have demonstrated several times that WasmEdge applications can connect to, say, Redis and the relational database and things like that. And having sqlx working is really I thought it's something that's really interesting. So and then after that we will talk about GSOD. We all know GSOC. Google Summer of Code, which we have. I think we have an opening slot. We're also sponsored by Google this year for GSOD, which is Google Summer of Docs. It's going to sponsor 2 documentation writers for the summer, and so we would really encourage everybody to. If you're interested, of course, to apply for that. So we were going to talk about that. And then if we have a little time left, I'm going to talk about something that are really interesting, at least to me, it's so we have been experimenting with how to use WasmEdge based serverless functions with, say, the ChatGPT and OpenAI. And we have recently integrated some of those facilities into our some of those applications that we wrote ourselves that running on WasmEdge into the WasmEdge GitHub repository. So it's very meta. It's eating our own dog food, so to speak, right? So I want to show you how that works, and you can try that on our GitHub repository now. That's it's very, very interesting. So yeah. So we have a full agenda today. So I like to start with the status report for the new release 0.12, and it has been a really, really long time since 0.11. The primary reason is because there's new features we want to add into this release, and because this release is designed to be, it would cause some API changes. Well, it's we don't really want to cause big API changes in this release. However, we have to accommodate some compatibility issues, especially and at the WASI level. We want to be compatible with the WASI socket proposal that Bytecode Alliance has been working on, which we want to make some. We want to support both the WASI socket proposal and our WasmEdge socket proposal, because we believe the WasmEdge socket proposals provide many more advanced features. So for instance, non-blocking sockets, domain sockets, DNS, TLS, and things like that. And none of that's available in the regular WASI socket proposal. So, however, the WASI standard itself does not provide a way to overload functions, so to speak. Same function take different parameters. So we would have to do things on our end in order to make it compatible, to make both versions of the functions work. And it was supposed to be released. 0.12 was supposed to be released last week, but at last minute there's some AOT issues. When you transcribe those, when you compile those into AOT binaries, on some platforms, WASI would throw a segmentation fault, and we don't know why. So so we are still trying to chase down that issue, and I think we are making pretty good progress. This week there's this week and next week there's holidays in Asia. I think it's also holidays for Easter's. So our goal is to work overtime, and hopefully we can get the software released during the holidays. So that's what's going on with that, and you can see that in our GitHub as well. There's some issues being worked on. So that's what's happening with WasmEdge. The new release of WasmEdge, and so yeah, well, the next topic, let me give a quick update on what's going on with WASM IO. So WASM IO is this very interesting conference that organized by the organizers of Spring IO, right? Spring IO is a pretty big conference in Java. That's it's perhaps one of the biggest independent conference for Spring framework, right? And because he sees, in fact, in this meeting, I see people who I met in WasmEdge IO, 7. That's so that's but yeah, so it's a very well organized conference with a lot of people went there. That's I've seen a lot of people from Texas. We've seen I've seen at least 5 people from Austin, and then another 5 people from Dallas. So that's it's actually quite surprising, because a conference in Spain, Barcelona, has so many Texans, right? That's but that's the state of the industry now. So anyway, that's so there's it's 2 days full of content, and there's lots of interesting talks, and I'm gonna highlight a couple, in a couple minutes. And I think perhaps one of the most interesting, well, I can talk about that part later. That's so a lot of people use it in production. That's one of the things I want to say. And also, this conference gonna happen next year at the same time in spring, in March, in Barcelona again. And so if you are thinking about using WASM in production, I think it's the right time to do it, because then you will be able to convince your boss to go there next year, right? Anyway, that's so let's okay. Yes, so Seven said all talks can be found on the YouTube channel. So he said in that chat, yeah, it's and the recording quality is really good. I really encourage you guys to check it out. So let me share my screen and show you a little bit about this. Okay, can I share my screen? Oh yeah, okay. So let me just share Google Chrome. Okay, so here is a tweet that this is our Twitter account. If you like, you can follow them. And here's a tweet that they sent out, which I find is really interesting. It said the 3 most viewed WASM IO videos are WASM GC related. So if you look at those videos, they all have like thousands of views. All of them related to Dart and Kotlin, those 2 languages, which I thought is very interesting, because when WASM GC first came out, by the way, WASM GC is a proposal to add a garbage collector into WASM. When WASM GC first came out, people say, okay, it's going to support languages like Java or .NET or even Go. Those are the traditional GC languages. But it turned out the WASM GC is too simple for that, or it's not. The GC itself in there is not sophisticated enough to support those type of languages. However, as time goes on, it has become really apparent and become really interesting that some other GC languages like Kotlin and Dart can be well supported with WASM GC. So I think those has become perhaps the most exciting use case for WASM GC now. So the reason WASM GC was first invented is actually not for server-side applications; it's for browser applications. So so if you think about WASM in the browser, it has to interact with the JavaScript runtime. The JavaScript runtime is busy drawing objects on the canvas, right? So by drawing objects and updating the graphics, it generates a lot of style objects, which on the WASM side, if you use WASM to do the computation, you have to process those things. So to have a native GC algorithm that you can process this quickly become very important for the performance of the application in the browser. So the browser WASM has become the pioneer and implemented those. So I think it's supported in V8 now in Chrome, right? So in Chrome, if you use WASM on JavaScript and WASM on the client side, you cannot take advantage of the WASM GC, and I think that increased performance a lot. You can search the internet, you can find a lot of those talks on contents, but from our point of view, we are more interested in WASM GC on the server side. So the languages like Dart and Kotlin are very interesting in a way that they span across both client side and the server side. Traditionally, they are used to develop UIs, like Dart is used in Flutter, right? And Kotlin is mostly used to develop Android applications. But I highly recommend you guys to check out those 3 talks. And it talks about the vision of Kotlin on the server side as well. Which really excites me because Java has been really successful on the server side. So there's no reason to say Kotlin wouldn't be successful on the server side, right? So I thought that's really fascinating. It's to see the vision that's those guys have for for this Java-like language. And in order for Kotlin to be successful on the server side, they actually have modified or updated the Kotlin compiler so that it can generate WASM GC compatible code. So it's like because it's like Java, so it has to have on the language syntax level, it has to. There's no way to claim more free memories, so so you have to rely on GC to do that. So so I think that's the importance of this WASM GC proposal. And so you can see here, that's they are really excited about that, and the community obviously is very excited about that. We are excited about that. However, only browser side WASM has implemented that. So what about server side WASM? So I want to show you some of the work that we have done. Let me show you the issue first. So if you can see here, we on WasmEdge, we have started working on this since a year ago, since January 30th. However, since we don't have a really strong use case, we don't know how it's being used outside of the browser. So it has been low priority for us for a very, very long time. But I think because of the push from the Kotlin community and also from the Dart community, we are speeding up the development process. So however, this proposal is complex because as you can imagine, it makes changes at the very fundamental level. You have to deal with new bytecode format and things like that. So so there are breaking changes and things that we would have to, because 0.12 is delayed for so long, so those PRs has to be delayed so they can be before they can be merged. So that has been frustrating for both for us and for the contributors. That's but I hope with the release of 0.12, things would change. So there's a lot of work our end has gone through that. So those are the issues and those are the pull requests. So you can see the discussion on the pull request. So and they don't pass the CI yet because of the breaking changes that happen in 12. So we hope after 12, we would have time to concentrate on that and to make this happen, right? So that's one thing. That's it's surprising, but it's also kind of reasonable. That's the most popular talks in the conference is GC related. People really want to see garbage collector in WASM. So the other big theme in the conference, of course, is component model. Although component model hasn't come out yet, but but the major players of component models are all there. Including Bytecode Alliance. Luke Wagner is there, and the major users of component model, including WASM Cloud and Fermia, Spin Framework, they're also there. So I think we are at the point where I think it's all the projects are talking about, when component model come out, we're going to support that, and we are the same. So one of the important things in component model is called WIT binding. Is that you have a WIT WIT interface file, and then you have a tool to generate bindings for those tools, for those host functions, so that they can be added to the WASM runtime. And this mechanism is very similar to the plugin mechanism that we introduced in 0.12. So from our point of view, we are very well positioned to support component model as well. One of the missing pieces is WIT binding, because from the WIT file to the actual code interface, this software is closely tied with WASM time. So our end, what we did is that, let me find this for you. I think it's in WasmEdge, but maybe not. No, it's not. It's in second state. Yeah. So from our end, what we did is that we created a tool called WIT-C, and WIT binding is it's essentially our version of WIT binding, but written in Haskell. So it's we have made it work with some of the components out there, including Microsoft's Slide. What's it called? I forgot. But the shorthand is called Slide. So so you have key value store logging and and things like that. So you can take a WIT file today and run through WIT-C, and WIT-C is Haskell based binding component. Let me see. There's another chat message. Spider Lightning. Thank you. Yeah. That's, all right. So yeah, I never remember things like that. But Spider Lightning components can be compiled. The Spider Lightning components and the WIT files can be compiled with WIT-C written in Haskell, and it would generate WasmEdge bindings, and you would be able to use it in WasmEdge. So so I think we are well positioned to support component model. When it came out later this year, I think we were promised it can come out later this year. So we're very excited. That's one of the major milestones in WebAssembly development, I think. And then on the other side of the coin, that's because we can't wait for component model to come out all the time, right? That's so one of the things that we the talk I gave is how to enhance WASM today. WASI today, at the conference is essentially basically I talked about our enhancement to WASI, our especially to WASI sockets, because we have the most use cases, because we are the ones that are actively deploying on WebAssembly applications as microservices in big companies, so that they can run sort of in their own independent containers. And I'm gonna show you a. Actually, let me go to my Twitter account. Twitter change their logo. I mean, I don't know what to think about that. So if you go to the real WasmEdge Twitter account, and you can see a link, and you can also get the link from the YouTube channel Seven just shared, about my talk about building database-driven applications in WASM. That's so our idea is really without any host function, just with WASI, you would be able to compile a Rust application and run it inside WasmEdge and connect to database in a way that is high performance, and that allows us to reuse a lot of Rust-based database libraries. Instead of learning new APIs and new host functions to do this. So the talk isn't that very long. It's about, I think, 25 minutes. maybe slightly more than that. So it goes through the use cases and why we do it, how we did it, and the use cases. That leads to our next topic in this community meeting, is that sqlx, because I think one of the more complex use cases for using the WasmEdge WasmEdge WASI socket is that it enables complex Rust applications that use databases like sqlx, which, like I said, I thought it's a JDBC for Rust, right, or ODBC for Rust. Because it allows a Rust application to connect to multiple databases. So let me see if Mr. Zhang is here.
Yes, I'm here.
Okay, great, Tricster. Yeah.
Okay.
So yeah, let me stop sharing, and you can take from here and talk about sqlx. Thank you.
Okay. Thanks, Michael. Okay, can you see my screen now?
Yes, I can.
Okay, so let's get started. Today I'm gonna introduce a topic about how we can port general Rust libraries to WebAssembly with WasmEdge. And I'll first talk about the general process of doing this. And after that, I'll take the sqlx as an example because it's fairly complex to do. And the first thing is to know what's the problem we are facing when we want to port a Rust library to WebAssembly. So basically, there are two kind of problems. The first problem is the network issues. And this is because there is no socket standard in WASM spec. And as a result, there's no implementation, whether in Rust standard library or other libraries. So if you want to compile the Rust code against the WASI target, you'll find the missing implications about these network functions. And the second problem we are facing is there are some C libraries that Rust depends on, like when we want to do the SSL, and we'll find that there are some crypto libraries are written in C, and Rust directly depends on these libraries. And for now, WebAssembly cannot use external C libraries, so you cannot use these libraries. But once we know the problems we are facing, we can find some solutions for these problems. So with the first issue, the network issue, we proposed a solution that we extended the WASI spec and add some socket function into it. As a result, we can create a crate called WasmEdge WASI socket, which contains some general implementations of sockets. So we can use TCP stream, TCP listener, things like that. And with this crate, it means that if you want to create some applications that use, network that does network things, instead of the standard Rust library, you can rely on this new crate. And as for the TLS related functions, we are working on some plugins to provide the crypto things, to provide the crypto functionalities, so that we can enable TLS over HTTP. And to be honest, WasmSocket is a rather low-level library. If you want to build something complex, build something big, you're gonna put a lot of that. You're gonna put a lot of effort into that. So we are building upon the WasmSocket. We port many common used Rust libraries to WebAssembly. Like first, we start from a simple MySQL client. This client contains some general functionalities of MySQL, like network communication and common data types defined for MySQL. So what we do is replacing the network functions in the MySQL client to use WasmEdge WasmSocket. And as a result, we can use, or we can successfully port this MySQL client to WebAssembly without any without other libraries. And the second project we ported is the Tokyo project. A Tokyo project is a big one. It's a big async executor. And many libraries are built upon the Tokyo. And more importantly, Tokyo provides a unified network interface that many libraries use. And we thought that if we can port Tokyo to WebAssembly and other libraries which use Tokyo can directly use this, can be ported to WebAssembly easily. So we did something that the same thing here. We replace the network functions in Tokyo with the WasmEdge WasmSocket. And we also did some other small stuffs like change the multi-thread executor to single-thread executor. And after that, we can use Tokyo in WebAssembly. With Tokyo ported to WebAssembly, other libraries can be ported to WebAssembly as well, like the async MySQL client. Async MySQL client is a library that depends on Tokyo directly. And it uses the network functions provided by Tokyo. And if Tokyo is successfully ported to WebAssembly, then the async MySQL client can be ported successfully. We don't need to do much work to do the same. And we also ported Hyper. Hyper is a low-level network library which provides the functionalities of HTTP. And there are also two libraries that are built upon Hyper. They are Request and Warp. Request is a HTTP client, and Warp is the HTTP server. So follow this chain. We first port Tokyo, then Hyper, and then Request and Warp, which means that after all of these things, you can easily create a HTTP client with Request and create a HTTP server with Warp in WebAssembly. They can be directly compiled to WebAssembly now. And here's the final topic, or here's the big one for my talk, that is the sqlx. sqlx, as Michael said, is a fairly complex project. It provides more and more connectors for various database like MySQL, Postgres, and Microsoft SQL. And it also provides some macros that makes writing SQL much easier. And let's see what we're gonna do to port SQL to WebAssembly. And here's the general process of porting a library to WebAssembly. We need to ask ourselves a few questions. Like the first one is, does it need modifications? Which means if you compile it to WebAssembly, does it tell you there's something wrong? And actually most libraries which does not use system level functions or network functions can be directly ported to or can be directly compiled to WebAssembly. And if they need some changes, and let's check what libraries are needed. Like for most of the async network, the async libraries which needs network functions, they depend on the Tokyo and maybe some other libraries. So next step is to port these libraries like Tokyo or Mio or libraries like that to WebAssembly. With this fundamental libraries ported to WebAssembly, the library we want to port is likely to compile. And maybe there's some, let's see, share. Sorry, let me try to do. Okay, down. Let's see. Now, if we have all these fundamental libraries ported to WebAssembly, then we can try to compile the library we want to port. And likely it will report some issues or some errors. And that's small fixes. We just need to fix these errors, and finally, this library should be able to compile to WebAssembly. As for porting the sqlx, let's check these questions. The first, does it need modification? Yes, and it needs Tokyo only. It's a library built upon Tokyo, and it uses Tokyo to create some database connector for MySQL and Postgres. And here's another thing. sqlx also provides a connector for, let's say, SQLite, but the connector depends on a C library. So for now, we cannot port the SQLite connector in sqlx to WebAssembly, as we said before. And if we replace Tokyo, we ported, and it should compile. But no, there are some other errors about the TLS. But for now, we don't support TLS. So next step is to fix these TLS errors. And after all of these things, it should compile now. And I think I should, review what I've done here. So here, this line, the sqlx depends on a library called WhoAmI. And it uses this library to provide the username of current user. And unfortunately, this library cannot be ported to WebAssembly because this depends on some system level functions. So we just comment out this line. And let's see here. It depends on the Tokyo library, which we ported to another library called Tokyo WASM. So in order to use a library that depends on Tokyo, what you need to do is to replace Tokyo with Tokyo WASM. And you don't need to modify the code itself. You just need to modify the cargo file. And one more thing, in order to use that, we need to change the multi-thread executor to a single thread executor. And that's because we don't have threads in WASM for now. And after that, we can use this example, like in the official repository. We don't even need to change the code here. We can just compile it and just run it. I have some results here. So if we want to use sqlx, we need to first export a environment variable. This is because sqlx did something when it did something during the compilation phase, that it expands macros to provide a quicker connection. So it needs to know the URL of database before you even compile it to WebAssembly. This is the first thing. And after that, we can compile the example to the WASM file, and then run it with WasmEdge. Don't forget to pass the environment variable to WasmEdge so that the compiled WebAssembly, the compiled WASM knows the database URL you are using. And here's the simple result of the program. And I think it's pretty easy to use a ported library because you don't need to modify the library code. You just need to change or replace the dependencies to the dependencies that we can use. Actually, I think let's go back to this kind of tree. Actually, since we port Tokyo to Tokyo WASI, so all the libraries that depends on Tokyo need have a version like Hyper WASI. They need to have this kind of, it's like a separate version because it depends on a different library. And for now, we need to publish all these libraries in addition to the official one. And I hope this can be fixed in the future. Like if we have sockets in the WASI spec, then we can have a standard to implement this in the standard library. Okay, I think that's all for my talk today. And if you are interested in, port a library to WebAssembly, you can follow the general process here. And that should be a lot of fun. That's all. Thank you.
All right, thank you, Tricster. Yeah, that's Tricster has been very modest, because he has pioneered a lot of work with porting high-level libraries to the WasmEdge WASI SDK, including all the dependencies that he mentioned. So there's a long tree of modified dependencies that we have to maintain at this moment, and part of the reason why we want to become compatible and eventually merge into the official WASI standard is so that we can merge upstream, right? That's also one of the topics that I talked with other guys at WASM IO, is to say, so we're gonna make a presentation at the I think the WASI group's weekly meeting, in the coming weeks, to talk about our approach and to see, because I think the way the AP they are used, our WASI WasmEdge WASI API is by far the most widely used, because if you look at other runtimes, they also can make database connections and all that, but they need host functions. That's where you need all those runtime frameworks like like Spring Framework, right? Like WASM Cloud, that's they all provide those host functions for people to do that. And however, the WasmEdge runtime allows you to just do it from the WASM, and that allows you to run like a container, instead of like a host application, right? So we've seen numerous use cases for that. In companies big and small. However, most of the cases I can't really talk about because those are internal use cases. But at the end of this conference, I'm going to give you some examples that I actually use the WASI sockets in live in production in open source. By the way, if you have any questions for Tricster, you can ask him. That's you can paste your contact information here so that people know how to get in touch with you. Okay, so because we have a compact agenda today, so let me pass over to Vivin to talk about the. Okay, so here's his GitHub account. You can find him, and and find him in our community. That's and if you have questions and comments and like to make a contribution, you can you can do that. So I'll pass over to Vivin to talk about the Google Summer of Docs, please.
Hello, can you see my screen?
Yes, we can.
Okay. Hello, everyone. Thanks for attending the community meeting. I want to share more details about Google Season of Docs. So firstly, I will quickly introduce Google Season of Docs. It is very similar to Google Summer Code. From the name, we can see the differences. Google Season of Docs focuses on the open source project's documentations. So Google will pay the technical writer to contribute to documentation to the selected open source projects. So that's how Google Season of Docs works. Next, I will introduce more details about WasmEdge proposal for GSOD. From the project scope, you can see that we need to complete three things. One is to reorganize the existing contributor documentation, and you can find the existing contributor documentation here. So the technical writer need to review the existing contributor documentation and then develop a new outline for the contributor guide and then complete it. So I also list some requirement content here, including the overview architecture, getting started with contributing, build WasmEdge from source. So you can find more lists here, and we also love to hear more suggestions from the professional technical writers. And the second project is to create a new WasmEdge plugin contributor guides. I will introduce WasmEdge plugin quickly. So WasmEdge use plugin to extend WasmEdge to add more features to WasmEdge. If you are doing when you are running AI inference functions with PyTorch in WasmEdge, you are using the WasmEdge WasmEdge plugin. From this folder, plugin folder, you can see we now have WasmEdge Crypto, WasmEdge WasmEdge HTTPS requests, and WasmEdge process plugins. The plugins here are all written in C++, but we also suppose writing plugins in Rust. Here is an example to use to add Rust TLS plugin to WasmEdge. It's written in Rust, but it's still under development, so we didn't publish it yet. And we also suppose write a plugin in C. We don't have a code example here yet, but we have unit test for plugins written in C. As you can see, we have code examples, but we don't have but the documentation for the plugin part is incomplete. So through the GSOD project, I hope we can have a complete WasmEdge plugin contributor guide, and then we could have more and more plugins. As an open source project, we can benefit from each other's work. The more plugins we have, the more features WasmEdge have, then we could use WasmEdge everywhere. Next, I will, okay. So we need two technical writers for GSOD. One is to reorganize the contributor guide. The budget is $3,000, and for the plugin part, the budget which is more difficult. So the budget for this task is $4,000. And the last question is how to apply for the GSOD. So if you want to apply for GSOD, first, you need to read the template provided by Google, and to write your proposal. You should include the following content in your proposal: your personal information, your professional information, especially for the documentation writing, and share your ideas about this project with us. After you finish, you could send the proposal to our email. You can find the email address here. And the deadline for the application is April 28th. Please make sure you have sent the proposal to us by April 28th. Before I finish, I also want to share that we use ChatGPT to generate 2 job descriptions to help you understand what we want. You can find the internship details, what is WasmEdge, and the requirements for each project, and how to apply. And I also linked some resources for you to understand WasmEdge and WasmEdge plugins. So I will send those links to the Zoom chat room, and I will also copy paste the links to our meeting notes. You can find our meeting notes here. So I'm done. Is anyone have any questions?
No, it's great. You know, so just to clarify, the JD you have showed is not written by you, right? It's written by ChatGPT, right? You just give it a few bullet points, right? Hello?
Yes, ChatGPT could help us generate content.
All right. Okay. So we have 5 minutes left, and you know, as Vivian has demonstrated, you know, there's we are using. Oh yeah, please. There's one question about plugins.
So can I ask it now?
Yes, please.
Yeah. I was there was a issue in GitHub, like the zlib plugin. We were discussing about that. You remember we were tasked to create a zlib plugin for the WasmEdge.
Mm-hmm. Yeah.
So I was asking, suppose we have a zlib app. Okay, it's compressing and decompressing, and it's testing, doing its thing. Okay, so we are going to how are we going to compile it? Like, it's going to need the zlib header, zlib.h header. If we create the plugin in WasmEdge, will our zlib program import the header from WasmEdge itself? Should WasmEdge provide its own header, or can it just use any header with itself, like from zlibng or anything?
So the way the plugin works, that's where the component model should be really helpful, but we don't have that yet. But so this has to be done by hand. It's you have zlib, and it's a native library, and it has headers, which allows it to allows other people to use it on the Rust or C++ side when they compile to WASM. They would be, the runtime would know to call the native functions once they see that, right? So it's very much like WASI. So you can see how other plugin does it, right? So the native library comes with its own headers. However, you have to make those headers available as a Rust SDK, or at least as a CSDK on the WASM side as well. So I don't know if you have to, in the particular case of zlib, you have to do it by hand, or you can have some automated tool to generate for you. But the component model, the idea of components like with C, like I just showed, is to automatically generate those interfaces. So you have a native interface that has .h, headers, right? And you import them into WasmEdge host functions. Then on the guest application side, when people are writing WASM application side, they would automatically have those headers because it can be automatically generated from the source. But I don't really think it's necessarily it's necessarily ready. So you may have to experiment with that, to at least do a few by hand and see if you can, yeah. I'm saying, yeah. Go ahead.
Well, the zlib library has a lot of functions. These are like normal C function exports. These are externs. But what I did was like I included the zlibng header. Okay. And what the important things are the structs. The structs are important because the WASM is 32-bit and most of the servers will run on 64-bit. But we don't care about the WASM memory model. Why? Because we know for sure that the structs are going to be 56 bytes because they will be padded on 4-byte boundaries. So we know everything. We know about the structs, how it will be represented in WASM. So we don't care which header it includes, which header WASM includes. We'll just get an offset to that ZStream module. We'll and we will just basically the WASM ZStream will be like a dummy thing, and we will do all the compression on the host side, and and we will just copy and sync all the state changes on the WASM to the host, and after calling the WASM library to again back to the WASM. So this way we don't care about it. So both ways will work. Right.
So I think I agree with what you have said, but let's have an example, so that why don't you submit a just to show one or two functions how it works.
Yeah, I've already completed. I have already completed deflate init, deflate end, inflate in whole thing, and I've tested an app, and I've already created a long GitHub post. I have also tagged you, I guess, Juntao and Haida. I have tagged both of you. I posted it yesterday, and I've also created a PR today. I'm re-implementing. I did those using the WASM CSDK. Okay, so now I'm implementing all these functions again using the plugin mechanism from today onwards.
Yeah, really appreciate that. That's we are probably slow in responding. Like you have seen, the GC proposal was submitted to us last November, and we still haven't merged.
I thought I would get some, but it's okay. It's okay. Your Vivian, I guess he's very active in Discord, and he told me to just directly create a pull request and talk there. So I did that. I'm writing a proposal right now. This is a proposal, and let's see how it goes.
Yeah, really appreciate that, and we will we'll get back to you as soon as possible. Yeah,
it's okay,
definitely.
It's okay.
Okay, thanks. Yeah, and it's going to be a lot easier than the GC proposal because it doesn't touch the internals of WasmEdge, right? It's mostly we are dealing at the plugin level. Thank you. Yeah, that's okay. Yeah, so let me answer those two questions in the chat. Do we know ecosystem. You don't need to know everything, but I think you should at least compile the WasmEdge and compile the plugin and run it. You should be able to do that because if you have not done that yourself, I think it's really difficult to write really convincing documents, right? We want documentation writers to be able to test what they wrote themselves. So the bottom line is that I don't think necessarily you need to have deep knowledge of what's going on, but you need to be able to use it at the API level and then to understand that. Okay. Okay. Yeah, that's good. And what experience? And yes, we're gonna. I expect. We expect to get a number of applicants, and they're gonna have their resumes and most. You can look at what's Google requires for the application materials, so the past writings and things like that. And we do wish to choose the best ones to to build good documentation. And so there's two person wants to ask a question. So let me have William, would you be able to unmute them so that they can speak?
Yeah. Hello, Michael. Can you hear me?
Yes.
Yeah. So I'm Rishikesh from India, and I wanted to work on the FileBeat project. Implementing FileBeat in Rust.
Yes.
Which is supported by WasmEdge and Docker. So I created a Google Doc, regarding a high-level architecture, because I am not sure about the scope of the project. What are the exact requirements? User requirements. So I've created a Google Doc which gives a basic overview of how we can implement it. But I don't know how do I proceed or where do I start exploring, to continue my findings on how to implement it.
Yes, again, this is something I need to get back to you, because I know it's delayed because I've been traveling, but but it is a important topic for us, just to to explain to everybody on the conference. One of the very interesting use cases of using WASM as microservices is to use that a log collector. As you know, you haven't probably heard of the ELK, the Logstash and all that. Those are all JVM-based solutions, and they are very heavy when used in a Dockerized environment because you have to have operating system, JVM, and all that stuff in Docker just to collect and analyze logs. And it is a tremendous effort, for a lot of companies. So we want to provide a lightweight solution based on Rust and WASM. So that's what this conversation is about. But but this is something we'll have to get back to you, probably this week. So if that's okay with you.
Okay. Yeah.
Thank you.
Thank you. Thank you.
I had a doubt regarding the serialization issue. Like we have to complete the serialization functions, but in the issue it has been mentioned that it is required in order to give the loader feature for the WebAssembly text format. So is that in the scope of the issue? Like, do we have to complete the feature to directly load the WebAssembly text format, or for now we just have to complete the serialization functions?
I think Haidai is in charge of that. Is he here?
No. He's
okay,
he's not.
He's on vacation. I think there's a national vacation in Taiwan. But let's take a note. I'll make sure that he responds to that. Because I think he's a mentor for this project. So I don't want to speak for him. Yeah.
Okay. Thank you.
All right, thanks. Yeah. That's that's I think that shows we have been slow responding, and part of the reason really is because we really absolutely very necessarily needs to get 0.12 out of the door, and so we were basically dropping everything to work on that, and I really apologize. Things has been I know I also on 7 email. That's there's just a lot of things that are piled up in other places where we have to do this. But hopefully you know, you know, the 0.12 release is going to be a good one. You know, that's and we're gonna have no bugs, and you know, and we'll be able to go back to those feature enhancements really soon. So yeah, that's so. One final thing, I just want to show you one thing that we added to the WasmEdge repository. Let me share my screen real quick. I promise it only takes like 3 minutes. Okay. 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 I think you should be able to see it. So we added a bot to our several of our repositories. You know, this is the main repository. What it does is that it summarizes a PR for you. So if you have a PR and if you say a magic word, it's gonna go to ChatGPT and ask it to analyze what's in the patch file. It's gonna summarize every commit. So in this PR, there's 8 commits. It tells you what's going on. It's right now just a description of what's going on each commit, but it's also summarize some potential problems, right? You know, that's and then provide an overall summary to it. And why it's interesting is because this whole thing is created in WasmEdge itself. Okay, this interaction with GitHub, interaction with ChatGPT, and you can see the source code here. So perhaps you can post the source code into the chat. You know, so it's a Rust application. If you can see, you know, it's not terribly long. You know, basically what it does is that takes a message from GitHub and then break it into parts and then send each part into ChatGPT, get a response, and then send it back to GitHub, right? You know, that's it's the logic is very simple, but you can see how to deploy it yourself. You can fork this repository and then deploy it on your repository yourself, right? You know, so you can go and in your fork you can change the code to point it to your own repository, or you can do we have made it easy to configure it through environmental variable as well. So if you don't want to change the Rust code, you just want to deploy it, you can you can go to flows.network, which is a deployment platform, and just to change the environmental variables for it. So, you know, as a final thing, I just want to show you, perhaps we can do something that's, perhaps we can do the plugin zlib. Oh, it already have it, but we can do it again. You know, that's, say,
well, it's quite intelligent. It took out a comment from my code and it just said it might be a potential problem. And it was indeed, I warned about it. And it works really good. It works really good.
That's good. You know, there are things that we still want to prompt, you know, because right now it's triggered when you raise a new PR, you know, so, but after that, you'll say the magic word to make it summarize again. But, you know, that's 2 commits, right? You know, that's, so let's choose another one. Let's choose, I think I saw one that's kind, maybe this one?
I have.
Oh, okay. Those all have it now. Okay.
You could try the WasmEdge.
The WasmEdge?
Yes. This one.
Okay, this one has 8 commits. Okay, this doesn't have summary in there. And so I'm going to say the magic words to summon the review bot. The magic words is flows, summarize. Okay. So it's going to take a while because, you know, for long PR, it needs to break it up. It needs to, because ChatGPT is very, very slow. But, you know, it takes maybe 2-3 minutes even, you know, that's, you know, that's, but the really interesting thing about all this is that all this are written in Rust and compiled to WasmEdge. And the reason why we can do that is because of the work Tricster has showed earlier. It's because we have we have networking access, we have Tokyo, so that we can run those worker functions. Those so each of the bots, so to speak, are a server, right? It's listens for incoming connections, and we can run those servers. We can run those things on the platform that in a high density environment. We just have one server for all this. And it can connect to ChatGPT. It can make HTTP requests, HTTPS requests, right? So now I said flow summarize. It goes to summarize it for me, and sometimes it's good, sometimes it's not great. So we are still tweaking it. So by prompting ChatGPT to make it say more intelligent things, right? So I encourage you all to play with this. And if it says too much, you can just delete it. You can just say, okay, I want to delete this. Okay, if you don't like it. So to keep the timeline clean. But I think this is something we'd really like to see everybody using in our community to help us to help everyone improve productivity here. So yeah, I think we are over time now. That's rare. So anyway, that's what I want to share. And is there anything else that's you guys want to discuss? Okay, there's more chat messages. Okay, great. So if there's nothing else, I think we can stop here and see everybody in the community. And I promise to get back to you guys, real soon. And please spread word about Google Summer of Docs. And documentation is something we really lack, and we intend to build really good contributor documentation through this program. Thank you very much, and I'll see you next month then. Okay.
Hello.
Yes.
Just if you have time, can I ask one question? One more.
Oh yeah, sure. Yeah.
Yeah. I saw on your website that WasmEdge was looking for the IoT space also, to go into the IoT space also. Like how much? What do you say? How much minimum RAM should we have on the IoT device to like sandbox and an application in WasM? Like I was given a task by our message to create an IoT project. So I wanted to I wanted to use this WasmEdge thing. I wanted to, but the problem is I was running a node MCU. It has like 300 or 500 KB of RAM. I guess that's not going to cut it.
Yeah, it needs to be able to run at least a very stripped down version of Linux underneath it, or a Linux-like environment, so that because it depends on POSIX and libc and stuff like that. So the smallest device that I have run are those Raspberry Pi Zero. Yeah,
but
so
Raspberry Pi Zero.
Yeah, Raspberry Pi Zero. So those single board chips, right? That's I was able to run that. However, I have not tried smaller ones. I think people have tried like ESP 32, but I think they encounter some problems. Those ESP 32, right? They sell for like $1 each. And it has Wi-Fi and CPU and memory.
Yeah, it is Wi-Fi. It is Bluetooth. It has like some Hall effect sensors. It has a lot of things.
Yeah.
It's so common. It's so common.
Right.
And today the Raspberry Pis are all sold out. We can't just get any stock of it. It's just virtually non-existent. That's the problem. Yeah. So
I think you can try Raspberry Pi Zero, because I have run it on Raspberry Pi Zero. I have seen other people do it as well. That's but not the latest version. So try it, see if it works. If it doesn't, then there are probably something other things we can do, because we can get the distribution really down to like 2 megabytes or less. But it's not in the official release, so the official binary package build are at least, I think, a couple megabytes at least. But I think you can change the build settings to make it build a much smaller binary. So I would encourage you to just to try to release on Raspberry Pi Zero to see if it works. If it does,
Yeah, I will see that.
yeah. Okay. All right.
Thank you.
All right. Thank you. Okay. So
Okay, bye.
yeah. See you next time. Yeah.